This breakdown is going to start with the underlying foundation of Google Meet and many other video conferencing platforms, which is WebRTC, which enables real-time video and audio streaming between many peers. Then we're going to talk about what Google Meet does uniquely on top of that layer. And finally, I'm going to rank the app based on these things at the very end, in addition to explaining what all this means for regular developers like you and me. So let's start with what WebRTC is and how it works. Come on. So in order for me and you to meet over Google Meet or Zoom, we need to share some info about ourselves. And we do that through an intermediary server called a signaling server in the WebRTC architecture. So think of the signaling server as the best romantic matchmaker. So let's say you want to go on a date with someone else and you have a matchmaker. The matchmaker in this scenario would get your info, get their info, find out when you're free, find out when they're free, pick a time where they overlap, then set up the venue, set up the time, let you both know ahead of time and just check in like, hey, are we still good then? Let's say your date has something come up, they can't meet in person anymore. The matchmaker will then set up a call so you can still meet at the same date and time, just over a different method. Then you connect somehow at the agreed upon date and time, and the matchmaker's like, just checking in. Hey, you guys are on your date. You're good. You both give it the thumbs up, and then the matchmaker's out of the scenario. All that is what the signaling server does in the WebRTC architecture of connecting over the internet. But instead of contact info, instead of a venue, instead of a call versus in person, it's coordinating what IP address you need to use. That one can get interesting because there are scenarios when it's not super clear what IP address to use, like if you're in a VPN or if you're behind a firewall or you're using a NAT, which lets multiple people share the same IP address. To handle those scenarios, it might use a relay server where it's routing all of your traffic through a different place, which it does know the IP address, and then back to your person that you're meeting with. That's all that work is going on by the signaling server during the connection phase. And the signaling server is not part of the WebRTC open source protocol, so it's up to the apps who are using WebRTC to implement this coordination. They'll probably use WebSockets or HTTP to pull it off, but that's up to them. All right, cool. So the connection's been made, and now it's time to turn raw data into packets that are sent over the internet. So in terms of audio and video, each person's audio and video data is encoded using the codec that they agreed upon earlier during the matchmaking situation. Codec just means a coder and a decoder. It encodes it so that it can be sent securely, and it decodes it on the other end so it can be accessed. So these codecs, the things that they help encode and decode include like light levels, frame rate, auto focusing, and adjusting when you change your screen length from horizontal to vertical, or you adjust the window on your desktop pane. There are a handful of them. That's why they have to go through that choosing process, but here are the main ones. We're not going to go into the differences, but there they are. Okay, so that codec helps turn the data, audio and video, most likely into a packet. Now that can be sent over the internet to the person you're talking to using a WebRTC API, a different one. This one is called the RTC peer connection. Okay, here's the cool part. So the person you're talking to receives that packet to their IP address. Then they use their codec to decode the data and then reconstruct it and then play it back on their device, which is simulating real-time chat. It's like if you had a zip file of videos, MP4s, and you sent it to someone and then they unzipped it and then played back the MP4s, except really quickly. Pretty cool. By the way, it's not just for audio and video. It can work for chat messages too. I'm very confident that Facebook Messenger uses WebRTC in this way for their text, for their chat messages. So we talked about the scenario of connecting, making the connection, and then the streaming of the data. But while the streaming is going on, the peers also have the option to monitor their network quality through WebRTC APIs. So they can see their packet loss, their jitter, their network connections, and all that can be used to adjust the quality of the video stream for them, like by tweaking the bitrate, the resolution, or correcting errors in a different way. Which in the simplified example is really cool because two people just connecting over the internet can do that on their own devices without necessarily needing a separate company or app or service in the middle to monitor and chaperone this connection for them. However, that is how things work like in the real world with Google Meet. Just because when you have more than one other person connecting, like say we have a group of 20 people, 200, 2,000 people, it gets really expensive to transmit that data one-to-one to everyone. So what they do is they put one of their smart servers in the middle, and then they come up with an intelligent way to route the data to only the people who need it at the right time. And that architecture is called a selective forwarding unit. And there's a lot of interesting, cool ways to do it. But for now, I'll just say, think of how meeting recordings work. So it's not necessarily required to record everyone at the exact same time. It'd be better to route things through this selective forwarding unit, this company's server outside of the initial peer-to-peer connection, and then that server can handle how to record it, how to replay it, how to turn that into an MP4 that you can download later. That's the basics on how you can use an open source protocol called WebRTC to connect and stream real-time audio and video data over the internet. And now it's time to talk about what Google Meet does on top of that cool tech. Let's go.
All right, let's dig in a little bit. Architecture time. Actually, surprisingly simple on the client side for an app like as computationally heavy it would seem as Google Meet. There's not much going on. So the CSS style sheet does not exist. It's just all in JavaScript. Are there third-party libraries I'm using? I'm not sure, other than some open source ones I've seen in the code. HTML is pretty simple too. We're bringing in a few images from their gstatic CDN, and there is some storage going on. There's definitely some storage. All right, we'll start with HTML. So one interesting thing is they're injecting your user info. So when you go to the site for the first time, it probably making a request, or it has it from caching already, and then it's putting it into a script tag, so it can be used later, probably for like the layout, for example, or getting our email to send to attendees or whatnot. So there it is. There it is. There's my Google account. So let's look at some JavaScript on. This is like an overview of the code on the site. What is that? Like a dozen, maybe 15 folders with a JavaScript file in it. And the code is minified, so it's like hard to see, of course, but it's normal stuff. There's so much going on with the WebRTC, but that is not built by them. So a lot of this code is just like managing the record button, making sure the layout's right, handling exceptions, normal stuff. There's definitely some checking for like what device you're on, which means to me that this is used a lot. Instead of it just being like the code I pulled up here on the desktop just for the desktop, I think they're using this kind of code for many of their platforms. Here's the CSS I was talking about. This is all in the index file, the index.js file, and all that stuff with CSS goes on for days. Look at all that. I honestly don't know why they would do it like that. I don't know the benefit of it. Here's what I mean about the cross-platform stuff. Like you'll see they're looking for if the event came from a touch or a pen or a mouse. So could this be the exact same code that's used on mobile or like on a tablet? Maybe. The more interesting stuff I think in this case is the storage. So here are our storage options client side: IndexedDB, cache, local storage, session, and cookie. And I want you to think, where is most of the data going to be on an app like Google Meet? Think about it. Let's look at cache first. Is there going to be a lot in cache storage? What we got? We got some fonts, just font variations. And we got one HTML file for if you're offline. So not a lot of cache. What about cookies? Bingo. A lot of stuff with cookies. Security stuff, connection stuff, codec stuff, SSID, which to me screams networking. So, I mean, they're encrypted and I don't know how to see the info in here. If you know how to get in there, let me know. I'm sure there's a way. Local storage, not much. But what they do have in there makes a lot of sense, right? So that's info about my CPU. And what that is probably determines like what kind of codec they could use, how high quality the video could be, what kind of impact that would have on the machine. It makes sense, but it's just surprising that there's not a ton of stuff, and where most of it is in the cookies. I like it. I don't know. That makes me happy seeing that. I want to talk about events, Google Meet events when it comes to a recording. So how they categorize it are there chat or message events, and then there are Meet events. So a meet event might be someone joins the meeting, someone leaves, someone is invited, whereas a chat event is someone posts a chat. You can connect to these events, like if you're making an app on top of Google Meet or like an add-on, you can check in and make sure you're handling these events, so you know what to do when someone is added or not. So all these add-ons, or it's like summarizing meeting notes or inviting people or doing unique workflows, like if this person joins or if this category of person leaves, like maybe we can act on it like that. You could build that in and use the Meet API to do that. But for Meet itself, I think the fact that they are sharing it like this does tell you about their architecture. They're probably using this internally for quality checking, at least parts of it, not maybe directly through the API like a consumer would through Google Meet add-on, but the data types, for example, I would imagine being very similar to what Google Meet is doing internally. So here we're seeing simple stuff, kind of bare bones, metadata, time. This data is, where the good stuff would be, but at least you see where this is looking like. And then we see a pubsub message, and they're pretty open about how this architecture is using pubsub. They also explain how they use a proxy, their own proxy. I'll talk about that in a sec. So your device, when you're in Google Meet, is transmitting the raw video, right? And we talked about the codecs and what WebRTC is doing with that. But in addition, it's going through Google Meet's proxy. And then it's going to the Google Meet's API, which we'll talk to later, which would help with imaging processing. Not all of that is over the network. Some of that's on device, but it's still like an external thing outside of Google Meet. And then the stream's updated back through the proxy to you and to the attendee. That's the normal video streaming portion of it. That data flow is going. But then the event APIs happen too, because both of these devices, like when they're connecting, are subscribing to a pubsub, like a server that'll bring in messages and do things if they come in and let you know about it. So that's where the reactions, the chats, the attendees, things are happening. I want to show you like an example of that. So in this example, I'm raising my hand in a meeting. So look right here, boom, right there, group chat received. That came through the event API. Show that again. So I'm about to click that there. Nice. So that was like me clicking that on here, and that event was transmitted to the other attendees too. So they could all see it in real time. Thanks to pubsub. All right. So that was a little more into the architecture and how it connects together.
You've seen how they're implementing their architecture. Now, I just thought through, like, how would I actually go about breaking up this app and implementing it myself? There's a lot going on in this app already. To just take one seemingly simple thing, which is like the ID you get when creating a meeting. So you create a meeting, you schedule it, they're going to create an ID, and then that's going to be persisted in their database somewhere. And then that's how they connect that to attendees and a time. Even like the length of that ID is important. If you go the lazy route and you just do a smaller ID, you could get video bombed. That's what happened to Zoom, right? Everyone got trolled because they had small IDs that they could just scramble and jump into them. So then Zoom upped it to like 25, which was a lot harder to guess. It's just not as good from a user experience perspective, but like it worked. I think they're down 2, and Google Meet actually is now at 9 characters. So you have to figure out how to make enough meeting IDs so that they're unique, but they're not easily cracked. You have to save them. You have to associate it with time. It's not that simple to just like create an ID. This is the code client side that's involved with it. So they are using this math.uuid library. I don't know if this is from the library or from Google Meet's implementation of it, but what's interesting, and there's a lot of like just hard-coded sets of like 4 or 5 regular characters, and they're using that to parse it or to create it somehow. I can't imagine those are like the actual IDs, but maybe it's like the seed for that, and then the math UUID is running on top of it and generating an actually unique one. I'm not sure, but I mean, just look at how many lines of code there are to creating the ID. let's look at some of the other things. The components themselves, for the meeting you have to build. They have to build a grid. There's different views. There's a lobby. There's a spotlight effect. We talked about the connections. We talked about monitoring and managing those connections that the apps have to do themselves. We talked about a little bit about adding an additional stream. So instead of just going client to client, you gotta go client to client to client to client and to your server, so you can do the interesting stuff behind the scenes to make that experience better. Subscribing to events. I won't read it. You can pause it if you want to look at it, but these would be like the features or the epics if we're doing Agile on how to create a production clone of Google Meet and some tasks associated with it. So any project managers out there, pause it, appreciate it, critique it. That's my best stab at it. One of the features of Google Meet and these other web conferencing apps that I think is actually pretty cool and maybe underrated are these video backgrounds and effects. We've gotten pretty used to it, so it probably doesn't feel different or new, but it is pretty cool. So whether it's Teams or Zoom or Meet, pulling that off comes with the step of separating the subject from the background. And to do that separation between person versus background, they're using a machine learning model which was developed at Google called Media Pipe. It's not necessarily for just Google Meet. It's an API that Meet calls, and it separates the foreground from the background, in addition to doing some other cool things too, like recognizing gestures or picking out faces from body, or classifying images and text. The other impressive thing about Google Meet's implementation of this separating background from foreground is it has to be really quick. So Meet is sending up to 30 frames per second. So they have to send all that data and then classify it really quickly and return the response from the MediaPipe API. So this whole project is cool. The MediaPipe one, it's open source and they have some cool demos. So check out the links in the description if you want to get in more on that. All right, time to start with the report card, starting with performance. So Meet is on par with Teams and Zoom. Depending on what you look at, it might be a little worse or a little better than those other two, but they're basically the same and it's not that noticeable. So for performance, I'm giving them a B+. Not like amazing out of this world fast, but solid, B+. Second factor is UX. So they have shortcuts for muting your audio and your video. They have different layouts like a spotlight or a grid layout. They have a chat. The chat is definitely lacking though. It's right now just text, no emoji reactions or files or like embedding links, and it's just very simple. They also have reactions. The reactions, there's not a ton of them, but they're there, and there's a nice overlay. Like if a bunch of people thumbs up at the same time, there's like a little splash and kind of nice. So none of it feels premium though. They're just going for what they need, and what they have added works. Because of all that, I'm giving them a B, a solid B on UX. The last factor I'm gonna grade is the product sense and positioning. So by this, I'm talking more about what the product owners have done, what the directors have done, the managers have done, the head people, not necessarily like what the engineers are implementing, but how are they positioning this app in the marketplace. It's come a long way since 2013 when it launched as Hangouts. It was rebranded as Meet in 2020. Between that time, it built Google Duo, which was a voice over IP product by Google, and then they combined those two into Google Meet in 2022. They also kept it web only, and everyone has a browser on their device, or they do have a mobile app, obviously. So they didn't need to make a desktop app, and I think they're smart for not doing that. It's well integrated, as you would expect from a company like Google, which has apps for everything and accounts, but it ships with Google Workspace right now. So business enterprise companies have this out of the gate. Like you can add events from Google Calendar and then just add a Google Meet link really easily. Their pricing's pretty simple too, so it's part of the Workspace pricing plan. You get Meet and Drive and all these other things for one price. But also, if you are a consumer and you're a power user, you can upgrade to their Business One plan. It's not that much. It's like their version of iCloud. So for one low price, you can get premium enterprise email, Drive, Meet, etc. So it makes it really easy to get on board because you already have an account with Google. So the takeaways there, it's bundled and it's simple. It's easy in terms of pricing. It's like a no-brainer if you're using those features to just upgrade for a little bit. So smart. So, okay, on that front, they get an A- for product sense and positioning. The only reason it's not an A+ is because I don't think they're trying that hard. They could make it an A+ if they wanted to, but I think they're reserving some of their resources for their other projects because Meet is part of the workspace. It's part of their ecosystem. It's not a new revenue stream necessarily for them. It's just more about retaining people and like making it possible for you to do everything you need to in the Google ecosystem versus like a new product line, a new AI, a new something. So A- on that, which brings our overall grade to a B+. Nice job, Google. At this point, we've talked about the architecture. We've talked about how Google Meet is implementing some of these open source technologies. But like, what does all this mean for regular devs like you and me? I have 3 points, 3 takeaways after studying this. 1, don't go cross-platform until you absolutely need to. Outlook has a PWA for their calendar. Google Meet or Google Calendar doesn't. Google Meet, there's no desktop app. And when you first hear that, it's kind of like, come on, it's 2024. We can't have it on all our devices, or we can't get a desktop app going. Like, they're obviously capable of doing that, but it's not necessary. And if it's not necessary, don't do it because it's a lot of work. If Google Meet can serve billions of people without having a desktop app, you don't need a desktop app for your little project or your MVP. Like, it can be web-based. Which brings me to the second point. Use web APIs. The web is back, baby. CSS is shipping some cool stuff. The web standards are coming out with new stuff. Meta frameworks like Remix, bought by Shopify recently, is really doubling down on what the web can do. There are startups or mid-stage companies like Vercel who are building upon the web and creating their own sort of cloud on top of these open source APIs. Don't underestimate what the web can do, and when possible, favor just using the APIs that are out there. The docs are clunky. It just feels like you're in a 90s website sometime looking around this stuff. But the point is, like, it can work. It can really work and get you very far if you just build upon a stable open source project that is the web APIs. Big fan. Third and finally, it's okay to have an okay product. Google Meet, I gave it a B+, but a lot of it was from the positioning. The product itself, how it looks, how it feels, is not premium, and that is totally okay. It's okay to just have something that works. If you're really quick, if you're smart about how you message it, how you launch it, and if you have a decent technical foundation that's not going to hamstring you too bad when it's time to scale, I think you should start out with an okay, maybe even a shitty version, and let that be okay. There's no shame in that. There's no shame in that. Hey, this video is made based on a comment someone left in the last breakdown, so tell me what I should make next. Subscribe, and I'll see you in the next one.